Okay, good morning to us teachers and my fellow friends. Today we're going to talk about the project for design for manufacture and assembly improvement of two wild soccer robot. So we are going to bring on the presentation for today. So first we came to the team hyper organization chart. So I am the Chu Bunxuan, which means is also the project manager. And then my fellow members are Guo Zhengxing, who is under the CAD and product design engineers. Yi Junfeng is a design for manufacturers engineers. And Daniel Harriet is undergoes for the design for assembly engineers. And the last people is the China Wang is a freerider at this moment. Also, we will highlight his name as the silver gray color as to show that he is a freerider lah. So as the figure shown in the presentation slide, the product that we selected is the two-wheel soccer robot that used to undergo the competition one. So next we go on to the product overview. So for the main function of this robot is to move forward and backward, turn left or turn right. This is a basic movement lah. Then we can receive the wireless command from PS4 controller. The mainly function is used to robot to kick the ball by using a solenoid driven front plate with an approximate about 20 millimeters of movement. Then the main component that we use is the PLA 3D printed part, ESP32, lithium battery, dual channel motor driver, two DC gear motor, two silicon driver wheel, solenoid driver modular, push and pull solenoid actuator, and a front kicker that print out. So next we go on to the problem statement. So from the problem statement here you can show is the complex PLA casing increase the material, printing time, and the cost because due to the 3D printer is from layer by layer, then is the limited internal space make components access and wiring is difficult. Because this is a competition, the robot should be the compact one, so the system wiring design should be very compact. It's also very hard to do. Then is too many separated parts and the fastness increasing assembly and maintenance time. And another one is the poor kicker alignment may cause friction or jamming.
So next come to our actual product view. So we can see there are three view, top, bottom, and isometric. So in the top view, we can see that there is two different types. First one is with casing, and second one is without casing. So with casing, we can see that all the motors in an electronic part is being covered, and without casing, we can see the full design for only the electronic part. So for the bottom view, we can see that there is a tiny black switch there. The one is a main switch of the whole entire system. So isometric part just showing the robot's view. So now we come to the products component part because just now we reviewed the complete set. So for the first part will be the most important part lah, the main body. Second part will be the motor. So this motor we need two in this robot lah. So below it will be the motor cover. We only need one of the motor cover because this motor cover can cover up two motor in once. And for the second row, first one will be the coupler. Coupler is used to connect in between motors, the shaft, and the wheel. Second one will be the wheel adapter because they don't want to change the wheel. Every time they want to change the wheel, they don't want to disassemble the whole wheel. So they have an adapter. So whenever they want to change the wheel, they just unscrew two of the screw, unscrew it, wheel can just directly come up and we can just put a new wheel on together. So they don't need to disassemble anything. And the third one, the last one will be the soccer rubber wheel lah. In this wheel, we can see that internal got a bit of 3D parts that are act as internal structure, which can improve the wheel structure, the wheel strength. And the outside one is the silicone part. So for the third row, first one will be the cover. The cover actually got two pieces, big and small. They are connected by using a M3 screw. So the bigger part is unmovable one. It just used to cover all the part, and the small part will be used to cover the battery. Below it will be the kicker case. Below the kicker case is the kicker itself.
Then this is the editing two-wheel soccer robot shown in different views.
So as we can see in the last slide is the isometric view and the three position phase view for the robot's entire 3D design. So here will be the bill of material of the entire robot. So first one is the soccer robot's main body, which only need once. Second part will be the motor, since we got two wheels, so we need two motor. And next will be the motor cover, since our motor cover is using one piece can hold two motor together, so we only need one piece. So we'll next come to the motor coupler, motor adapter, and wheel. So these three things we both need two lah, because we got two pair of it. So the continuous one will be a top cover small and top cover large. This one actually is split into two part one, although it functions as one complete part. But in printing we still split it. So in BOM we also split it. And next will be the kicker. So kicker, there are two parts. Actually, one part is the kicker case, and another one is the robot kicker itself.
Now moving to the BOM for improved design. So for the existing design, we got 14 parts. So we are decided to reduce the part. So for initially, the separate kicker case can be eliminated and then integrate into the main body. Second, two motor couple and two-way adapter can be integrate become the two motor wheel hub. And for addition, the cover and the top cover fastening method can be simplified a bit and using the Cathie fastener feature. Now moving to the DFM concurrent costing. So it significantly that show the physical part, PLA component, PLA materials, and FDM printing time is significantly reduced. And it results to our FDM 3D printing cost is reduced also. But for the purchase component, since we cannot find a similar product with similar function, so it will be better we use that for the purchase component to achieve the best function for the robot. Well, for silicone wheel material and casting cost, for the casting, we are using a 3D printing case just for 1 ringgit. Well, for silicone wheel material, since we are purchasing two bottles of silicone with type A and type B, we mix together with specific ratio to achieve the silicone we want. And then one bottle is 20 ringgit. While for fastening wire and connector, since fastening the screw and nut is we use is resulting for the improved design, but for wire, since we integrate the cable routing channel and we do a optimization for the internal casing arrangement, so the wire need is reduced. While for labor and finishing cost is remain unchanged, so the total estimate product cost from 444 ringgit reduced to 384.60 ringgit, and each significantly cost reduction is about 33% 0.38. Now moving to the DFA comparison for existing and improved design. So we can see that the BOM part is reduced from initially 10 become 8. For vertical part from 14 will become 11. While the motor couple and wheel adapter is combined into integrate hub. So from 4 become 2. While the separate kicker case is integrated into main body, so the improved design is disappeared. Well, the improvement includes cell locating motor compartment, locating tab, cable routing channel, standardized fastener, Cathie screw, and accessibility for the top cover. Though we believe this feature will minimize component alignment, complex tool chain, loose fastener, wire interface, and unnecessary disassembly. As a result, the robot has better access to the motor, battery, electric component, wire, wheel, and kicking mechanism. So we believe each benefit for inspection, repair, and replacement.
Finally, we have our conclusion or summary for our project. We- So for this project of a two-wheel soccer robot, we have applied all the FMA design for manufacturing and assembly theories to redesign a two-wheel soccer robot. So as for reduced parts, we have reduced the parts from 14 to 11, where there is 21.43% in reduction. Reduce PLA material by 27.2% and printing time by 30.93%. As for cost, we have lowered our cost from 444 ringgit to 384 ringgit and 60 cents, which there is 13.38% in saving. And lastly, we have improved assembly and maintenance work for this product while maintaining all original functions of a two-wheel soccer robot.
So that's all our group 2 presentation. So thank you so much for listening.